need more gain, up the gain and exposure. There it is. Oh, look at that. Wow, how about that? Okay, so now what I'm able to do is look at your comments on the queue, and that I'm looking at that on my phone. So what I think I'll do here is, I think that's centered well enough. I think what I'll do is, I don't know why our live stacking's not going to work, but let's don't worry about it. I don't know why our plate solve is not working, but let's go up and start the live stacking. Let's let's come over here and reset this and auto stretch that. Then let's reset this and auto color balance that. Then let's reset this and auto color balance that. And look, no ignored frames so far, so that's good. Let's clear this. Now let's take the black and let's set it somewhere about right there. And let's color balance on peaks. And, that's actually interesting, isn't it? We want to set that about maybe somewhere in that neighborhood right there. And then what we want to do here is try to get a lot of that nebulosity without introducing just a bunch of sky glow. The moon is at half luminosity tonight, so we're going to see a little bit of the moon. Now, what are we looking at here? This is M42 rats. I didn't put the name in before I started live stacking. This is M42. I move this white level all the way up here. And M42 is the Orion Nebula. Uh, if you've ever gone outside and seen those three belt stars, uh, those that's what we're looking at right now. Are those three belt stars? Um, and below those belt stars, this beautiful nebula. It's when Charles Messier did his cataloging back in whatever I forget 1700s. He named this nebula M42, Messier 42. And this is probably one of the brightest objects in the sky. Um, you can almost see it with your naked eye if you have good eyes. And all that nebulosity, those clouds that you're seeing there, it's kind of almost like a star forming region. Um, and this patch is famous down through the years, and you can see references to it in all kinds of books and literature, and seems like it's even in the Bible once, isn't it? Let's Google that real quick. Let's go out to the Bible, and I'm going to say Bible Orion Nebula. Surely that's not in there. What does the Bible say about Orion? For behold, he who made the Pleiades and Orion, and turns deep darkness into the morning, and darkens the day into the night, who calls for the waters of the sea and pours them out on the surface of the earth, the Lord is named. I mean, this goes all the way back to Job 9:9, when uh, is it God speaking when he says to Job, "Who made the bear and Orion?" So this constellation and this particular nebula has been seen down through the years. Of course, later in Job chapter 38, can you bind the chains of the Pleiades or loose the cords of Orion? So this thing that you're looking at has all that history in it. And what we're going to try to do now, you see we've got 35 frames, we're working on 3 minutes. And I wish we could make this bigger. Let's go back over to our silly OBS and let's figure out how would we make this, how would we change this resolution if you were a Okay, so I've right-clicked on the Sharp Cap window in OBS, and I'm looking at, why don't I do properties? Wow, that's a mess. Um, wow, capture method automatic, window sharp cap. Um, but why can't I make that bigger? I'm looking at my cube. Make sharp cap bigger on our screen and larger image if you can. Sanjeev, good luck, Doug. Nice meeting all of you virtually. Stay safe. Thanks, Sanjeev, for stopping by. Hit the lightning bolt under the red. Oh, somebody wants me to color balance. Let's do that. Who was that said that? Shadow Storm. Al. Thanks so much, Al, for reminding me of that. Okay, so we're going to hit this. That put a little more green in it, didn't it? I think I'll maybe pull this down a little. That'll make it a little bit bigger for you guys just because, boy, I almost think that I don't like that much green in it. Do you? I think it looks a little bit weird. Let's try that one more time. There we go. Fiddle with this black a little bit. Somebody told me not to make the sky totally black. What we're doing here is we're messing with these controls in order to try to show as much of the nebulosity. And the nebulosity are all those clouds, all that dust in the star forming region. Let's do this. Let's try color balancing. Oh, that's ugly, isn't it? Let's go back to that. Well, anyway, you get the idea. There's Orion. You have a double stretch going on. What does that mean? A double stretch. I don't know what that means, Frank. Reset right histogram. Are you kidding? You want me to reset this? Okay. And then let's reset that and this. And then reset that. Boy, that is just not big enough for you guys to see, is it? Wonder how we can, there we go, a little better. And let's pull this in. And let's do one more of these. Wow, look at that. Look at all those clouds. So the funny thing is, every night when you walk outside to walk the dog, the Orion Nebula, M42, is right up there for you to look at. And what you can do is look for those three belt stars. And below those three belt stars, somewhere in the neighborhood of where the sword would be, if the guy stuck his sword in his belt, you'd see this. Okay, we're at about 6 minutes. I think we're going to save this and move on. So we're going to save exactly a scene. Wow, look at all that. Amazing nebulosity stuff. It's just amazing that that's up there all the time, every night that we look up in the sky and we see those stars. It's up there. Let me just pull this down for a minute and center this a little better. Look at the way we're starting to see all these threads out. All those little, wow. It's beautiful. God did a good job on that, didn't he? And still does. Why don't we get the live stack back? Oh, that's weird. Pin that back up the way it was. Save this one more time, except, uh, yeah, and then let's stop this. And now let's go back over to our Sky Safari, to our planetarium program. And let's let's try the Andromeda Galaxy. So what we're going to do is, boy, I wish we could get our webcam working. So You guys could see the mount moving. I had that working the other night, but that was in Skycam. Um, oh, Frank is saying it's all reversed from Arasa. You know what, Frank? If I were sharp enough, I should reverse that back so it's correct, huh? Right. What Frank is pointing out is a particular kind of optical tube assembly, or OTA, the particular kind of telescope that I have. It's an 8-inch RASA, and it brings the light through a corrector plate, bounces it against a mirror in the back of the scope, reflects it back up to uh, a camera that's mounted on the corrector plate, so to speak, out in front of the scope. And because it's basically only reflecting at one time, it reverses it. Just like when you look in a mirror, your image is inversed. It also inverses things. And what that means is um, the image that Frank is noticing is is reversed from what he sees it in his telescope. And Frank's probably got something that has an eyepiece on it, like a Newtonian of some kind, or maybe a Schmidt Cassegrain, some kind of an eyepiece that that has introduces one more mirror in the image train, and that mirror reverses it back. So when Frank looks at the object, he looks at it just as if you looked at it up in the sky. Whereas with my telescope, you're always seeing the reverse of what the object really is when you look at it in the sky. And so what we can do in the software, I think, is reverse it back. But for right now tonight, I'm just thankful just to have a live stream going on. And so what we're going to do is we're going to reset this uh, histogram here. We're going to go up to our gain, and because this is not as bright, let's up this gain to about, let's start out at about 200 and go ahead and put this at 10 seconds just to get started here. And what we'll want to do is make sure we frame this correctly. And let's again, oh, before I forget, let me, Andromeda, um, galaxy, and this was also spotted by Messier back in 17 whatever. He called it M31. He made his catalog actually because he was a comet hunter, and he would see little splotches like this, and he would say, "Boy, I don't want to get that mixed up with a comet." So he was basically naming the things that he didn't want to see. But in the process of naming the things he didn't want to see, he created not a half bad catalog for those of us who do want to see things. And that's the interesting thing about all this is that uh, when we look up in the sky today, we're actually looking at the objects in many cases that he didn't want to see because he was looking for comets. And we love comets and all, don't we? But let's put this at about well, let's put it about 15 seconds for a second, and then let's go back down here and reset this and reset that, and then let's go back up and bring this gain back down, because now we've got too much exposure. Look at that, 10 seconds. Now let's reset this and that. Wow. I'm thinking our framing is going to be okay. If we ever get our exposure correct. Okay, now we're talking. Now let's try plate solving again, shall we? Just because we're going to live dangerously here. Oh, solved. Repositioning, recentering. About that. So now we've got plate solving, and what this means is we can now look a little more carefully at our objects because the software is finding them for us. with its database. It's looking at the database of all the things that it's collected down through the years. And then what it's doing is it is comparing what it's seeing through the telescope with um, its database. And it's saying, okay, I think I know where you are in the sky. And then what it does, it starts um, trying to work out a little bit of a rubric of what you're actually looking at. So what we're looking at here is Andromeda Galaxy. This is a spiral galaxy. And let's do this and this, by the way. And this again. It's a spiral galaxy. Let's get this a little bit bigger here. And look at that. So what we're doing now is we're kind of trying to tell the software the part of the picture we're interested in. And what we do over here is we actually try to work on the color balance because the software doesn't know for sure what color is which very well. And that all that cloudiness that we see there is the actual galaxy. I mean, you can make it real obvious there, but that's the actual galaxy and all the dust. And then if you look over here, you can see a black area. That's like a maybe a dark area between dust lanes of the spiral arm, or maybe some dark nebula. Let's pull this white all the way back over here if we can. That'll give us some room to work here. So now we're about 2 minutes and 15 seconds in on this object. Now, when an astrophotographer um, looks at this and tries to take, let's just live dangerously and do this for a second. Okay, we're doing that. When an astrophotographer looks at this, what he does is he spends maybe, 2 hours on an object, or some objects he might spend 3 or 4 or 5 or 6 hours. You see, we have 2 minutes and 40 seconds so far gathering light on this object, and he would spend so much time gathering little photons about this object, and that allows him to gather so much detail. Whereas in our case, we're really just interested in observing the object for a while and then moving on. We're not really going to do a picture of it that we want to post process and play with all the colors and light and take pictures on a monochrome camera with 3 different filters in front of it. There are 3 different colors. We are doing the kind of astronomy you call EAA. It's electronically assisted astronomy. We would normally be looking at this through an eyepiece, but we are actually looking at it with a camera instead of an eyepiece. And what that also does is the fringe benefit of letting you look at what the camera is seeing. Um, and that's really not capturing a picture so we can send it in for some magazine. It is more trying to observe something for the sake of saying, okay, I kind of get an idea of what that is. And how amazing is it that that's up there all the time? And it's very wide. I don't know if we back up all the way, if you can see, let me get rid of this for a second. Look at how wide it is. I mean, this thing is so big that some cameras, you wouldn't be able to get all of it in. And then there are, in this particular picture, you can actually see a couple of extra images, which kind of make it interesting. Um, you can see M110, which is out at quite a distance, out here far from it, and then you can also see perhaps a closer galaxy if we look really close, and I believe that's M32 if I remember right. Let's see if we can see that. Let me go back and let's zero in just a little bit. What would we do? Go here? No, maybe here. Now I'm using 2x2 binning. So you notice when I get real close like this, my resolution on the camera I'm using, it begins to pixelate a little bit. But the reason I'm trying 2x2 binning, for those who are in the hobby, I'm thinking that with the bigger pixels that I gather more light, and that lets me start trying to see things a little better. Yeah, let's go ahead and call this as our M110, and let's do a guess that this is the M. Let's do a guess that that's the M32, and of course this is the big Andromeda galaxy, which is the M31. So you're actually seeing three galaxies here for the price of one. I think probably that gives us an idea. This is up there all the time, and it's the kind of thing that you could see. Really, if you had a pair of binoculars, you could see a little bit of it. But what we're picking up because of the larger benefit we get from the larger telescope are we're starting to see a little bit of that detail. Look at these dust lanes and that blackish where it's the dust lanes are blocking out the light from the star forming regions and all. We're blocking that out by looking at this larger telescope. So let's bring our live stack screen back. We'll pin that up here again. And look, we only dropped one frame that whole time. That's not bad at all. 6 minutes exposure. So let's go ahead and save a copy of this. And you know what I'm going to do also while we're at it? I think I'm going to bring up the targeting software that I use one more time just to see if maybe this time I can connect to the scope. So we're going to try. Nope, still no response. So there is something wrong. Maybe in this software it has recorded somehow that. No, I don't see ASCOM configure. Oh, you know what? I think it's because we were not set up to use. Aha, now look at that. Look at that. That's looking much more promising. Let's close that and try this again. Now we're going to try to connect to the scope. Look at that. Okay, now our targeting software is connected. So you just got to keep going back on this stuff, don't you? So we're back. Before we leave this, let's make sure, let's see, we did save it. So let's stop live stacking. And now let's let you look at the targeting software. So I'm going to point OBS to the targeting software. And then in the targeting software, let's uh, let's do this thing. Let me see what you're able to see in the targeting software, because I think I can see. Wow, that resolution isn't correct either. look at look, you're just seeing a small piece of that, aren't you? That's so sad. Uh, I'm gonna have to work out that resolution some night when I'm gonna go here and look at how can I how can I tell it not to show all these silly widgets. Um, let's go to File, Edit, Preferences. Can we tell it not to show? No, it doesn't look like that's where it is. But see how you're seeing all these silly widgets here, and that keeps you from seeing. But anyway, you get the idea of what I'm looking at now. I'm going to sort the list by visibility and altitude. And just for fun, real quick, let's point the scope at Mars so that we can say that we went to it. And I'll look out yeah, the scope is slewing. and it looks pretty happy. It's settled down. Uh, by the way, we did look at M42, so I'm gonna make a quick observation there and say something like, let's see, 42. Why am I not? I'm not even able to see the bottom of my screen there, am I? New observation. Well, I think it'll record an observation anyway. And we also did uh, M31. So I'm going to look for M31 real quick and just, oh, I didn't find it. So we must not have had M31 in this stack of targets tonight. So we did an observation there. Now we're at Mars. So let's go back to let's point you now at SharpCap. Now the view of Mars is not exactly life-changing because of the fact that, I'm going to put Mars in here, because of the fact that we have a very wide field scope. That's Mars. And so you say, that's Mars? It just looks like a dot. Well, yeah, I mean, that's the truth. If you look at Mars at night, it just looks like a very bright star. We can zoom in on it a little more, but keep in mind, because we're using that binning, 2x2 binning, it is not beautiful. And look how the exposure is so tricky on planetary stuff. Um, what I would like to point out is just, first of all, get an idea of what that looks like. And then we're going to make it so we can see the stars around it. Let's give it like 8 seconds or something so we can start seeing some other stars. And when you compare it to the other stars, yeah, see there's a star there and a star there. And you can start saying, okay, I kind of get that. The stars look like little pinpoints, and Mars looks like a disk. And really, to be honest, with the wide field telescope that I have, and with the way we are, oh, that set the gain on 20. We didn't want to do that. With the way that we are, uh, the way that we are blowing out the planet now when we're looking at stars, but you can see how much bigger Mars is as a disk. Now, it's not going to help us to do any live stacking on this. I don't think we're going to get any good out of this at all. But at least you can say that you observed Mars and you could see what a bright and a wide disk it is. So there's something to be said for that, I guess. Uh, a planetary scope would zero in on that, but it might not be as good, for instance, at gathering those dust lanes so quickly on such a wide field as Andromeda, for instance. So every telescope's a little bit different. Again, we are blowing out Mars, but if we what I wanted you to see was the star points and then the difference with that with a planet. And that's basically what we're going to see. We're not going to see much detail. Now, what we can do is cheat a little bit. And with our Sky Safari uh, software, we can actually show you. And let's go back over here and look at Mars. See how it's showing us all those pinpoint stars, and see how it's showing us that Mars is a disk. So basically, we're seeing the same thing that the Sky Safari is showing us. Look at all these pinpoint stars, and here's the disk of Mars, but there's no detail, see? And honestly, the fact that we're not seeing that detail in this planetarium program is showing us what we're seeing in our field of view here. This rectangle that you're looking at in Sky Safari is a simulation of the rectangle that you look at when you come over to SharpCap. See, that rectangle of the camera is showing you roughly that idea. When we broaden out the rectangle and don't zoom in on it, I should say, in SharpCap. So, but let's do cheat a little bit and zoom in. Now what we're doing is we're cheating and we're actually using a surface map of Mars that has been gathered by the satellites that have visited Mars over the years, and they have been able to map all of Mars, and you can actually see it almost like we look at the craters of the moon now, can't you? Look at that. And now we're, see if I center on it here, selection, center on object. It brings back the middle and it keeps it from fading. But all these craters that you see are just like the craters, really, they remind me, don't they? They remind you of the craters on the moon. And look how when you get really close, you can see where the object hit the crater and it pounded it so hard that the material dropped back down into the crater and left that little pile of debris in the middle of the crater. That's what we would see if we were orbiting Mars like a satellite. But we're not. We're looking at Mars through a wide field telescope, and all we're going to see is, Mars as a disk. But at least you can, tell your son or daughter, relative or sister or brother that you looked at Mars through the telescope tonight. So there you go. That's Mars, and we're going to save a picture of it just for the sake of having a picture. Let's see. Clear this and set this on auto, and then come down here and auto that and stretch that, and then reset that and color balance that, reset this, stretch that, bring this white over here, reset the color a little bit, bring this black over here, a little bit to the right of those. Look how we're overblowing it. See how it's so overexposed in order to see those stars. Let's back this down. Let's back this down to 4 seconds and lose some of the stars. Set this on auto again. And let's just enough there so that we have the image. We're still overexposing it. But let's just save the image so we can move on. Okay, so welcome to Mars. Back at our targeting software, let's put you back there with me, even though with resolution, you're not able to see much. And it also is wasting so much space because of these silly widgets here, isn't it? Wow, that's so sad. What if I did that? Does that help you any? Let me see when my resolution is all messed up, isn't it? Let's go to this. It's the beehive cluster. So we're going to slew to that object. It's M44. Oh, I see here I double stretched. Sorry about that. I got to learn what's doing that. Okay, so our telescope is slewing. We're going to M44. It's called Pricepe. How do you pronounce that? The beehive cluster. And it's also known as NGC 2632. Some people somewhere have called it the manger of all things. So the telescope is skewing okay, slewing okay. Boy, before this night is over, I'd like to work out that webcam so that you guys can see it robotically slew through the night. The telescope is an 8-inch RASA. It's a Roe Ackerman Schmidt astrograph. It's really made like a giant camera lens, and you mount a camera in front of it. So there's not even an eyepiece on it. You can't go out there and look through an eyepiece. It is totally captured electronically. It's on uh, a Skywatcher mount that really I'm loving. And it's on a heavy duty tripod. Then there's cabling that comes in out of the cold. And I don't know what the temperature is out there. You would know it better than I right now. It's pretty cold, probably, I'm guessing mid 30s. Let me just check and see. I'm just going to go check and see what we are outside now. Weather here. Um, let's see, 30 degrees. Actually, it's below freezing. 30 degrees. And look, it feels like 24. So, it would be just oppressive to sit out there. I mean, some guys do it, don't they? But now I'm inside and I'm looking at, I've dialed down my thermostat here in the back of my SUV and I've put the thermostat on 70 degrees and I'm still warm. So it really is a lot more fun to do astronomy this way on my laptop inside. Okay, so now what we're going to do is go back and set you guys on the sharp cap window. And then we're going to right away stop live stacking. And we're going to name this M44. And let's go down here and reset the display histogram. And this is on auto. Let's also bring up now our live stacking and clear this and color balance that on stars or color balance it on the hoops it's starting to see. Look at that. It can't find what to color balance on. So let's color balance on stars instead. And this is our black level here. Al is saying, sure don't need binning. Okay, I'll fix that. I meant to do that before. I just did not get a chance to shoot new darks. And so I'm still working off of my old dark frames that are shot at binning. Um, so I'll get that fixed by next time. Give you my word. And these mids, I'm not sure they're going to show us that much because what we're looking at here now is a cluster. And you know what's interesting about this Sky Safari thing? You can actually, I wonder if I wonder if you can hear it if I go like this. Can you hear that? Okay, so I'm going to look and see. Oh, yes, you can hear it. Thanks, Shelley. Um, Now, clusters don't seem to thrill some people as much as those galaxies, but I gotta say, I actually like them. I don't know why. I get such a kick out of it, but I know a lot of people don't. Now what does this do? Is that like some kind of? Is that like some kind of like the hit the lightning bolt under the red and reset display histogram? Thank you, Al. Lightning bolt under the red and reset the display histogram. Huh. Okay, I'm resetting it. Hmm. Boy, it's a mess. Look at how the blue. I think it's just because I'm using the Celestron light pollution filter maybe, and it's not seeing a lot of objects that it knows it can set its color balance on. Black to the right. So it's unable to color balance much, I think. That increases color saturation. Thank you. Is that Al? No, that's Frank. Thank you, Frank. Yeah, this is color saturation then. So let's back that off back down to where it was, 1.1 or whatever, because we don't need to dial up the color. Like I say, I get a kick out of clusters. Um, Set this on auto. I think it's because I I am amazed at the amount of distance that we're looking at here, the amount of space in between all these. I mean, this has what you're looking at here. It has so much space between these stars. And keep in mind, this is like way far away from us. Over 600 light years away from us. And the amount of space, the width between these stars is just phenomenal. And for some reason, I just think there's something beautiful about seeing uh, this much space with this many stars. I don't know if we started counting these. I think we would get very close to 100 stars here in this cluster. And if we get a larger telescope and really, if we started really live stacking this, for instance, in fact, let's just see what happens in our live stack. We are live stacking, so we've got no ignored frames. We could continue to just draw more and more photons out of this. Oh, we've got some other things going on here. Black to the right, now lightning bolt. Oops, black to the left. Oh, okay, sorry. Black to the left. I don't know, that brings in a lot of green though, doesn't it? Black to the left. The black level should be set very close to the peak once you have color balanced. Then play the midtone slider, bring out detail. Considering you have only been observing a few days, you're doing super, and you really seem to enjoy the process like the rest of us. Yeah, that's right. You've got my number. Was that Frank? Or you aren't color balanced? That was Al. Yeah, you know what, Frank, when you say you aren't color balanced, you're saying more than you realize. I am color blind, to be honest, color deficient. Uh, Let me pin this back up there for a second and reset this. Now, I don't know whether to use that auto stretch. I'm not going to do that. But let's redo this and that. And then let's redo this and that. And then let's bring this over to here and this over to, now it's super blue, isn't it? Oh, look at this blue. You know what we could do, guys? We could we could manually balance. Yeah, we could manually, like, look how we don't have as much blue now. Let's give ourselves a little more blue till we manually get the blue over there. And then let's move this black as close as we can. And then let's bring a bunch of those in just right before we start getting those clouds. How about that now, guys? Black in the middle of the mountain. Oh, in the middle of the mountain, you're saying. I'm game to try that. Black in the middle of the mountain. And then what? Move this away to try to get rid of that? How about that? make this bigger now just to see what we've got. What do you guys think? Okay, again, this is M44, and I think it's fun. Let's save this, and we've got our name correct. So there it's saving M44. And then let's stop live stacking this, and let's go back to our targeting software. Let's go back here and say, what happens if I say make a quick observation? Huh, well it did. That's pretty quick, all right. Now it's suggesting, let me just do a sort of the list again. What this does is yeah, it's sending us to a place, to an object called Clark 105. So let's go to that. Slew to Clark 105. It says it's at 80 degrees altitude. And it says this is a nebula. Yeah, we are slewing okay. It's wow, that's just beautiful. Wow. It went about maybe I'd say 15 degrees past the meridian. So that's probably about as far as we want to go past the meridian. You like it brighter. I think I'm going to do it brighter next time. I like it brighter. So that's what I want to learn how to do because I've noticed that all my pictures are dark. Honest. The little snapshots that I take. All right, so this is supposed to be slewed, and let's go see what we're looking at. See, we are Clark 105. So tell you what, let's put you guys in Sky Safari for a second, and let's search for. Can I just say C105? No. Oh yeah, C105. So this is what this is. It's a globular cluster. Okay, so that's what we're looking for, C105. So let's center that. Oh, now it says it's below the horizon. Are we sure we're pointing to the right thing? Clark 105, it says it's a dark nebula. I bet C105 is different. So let's go back to our planetarium software after all. And let's put in the word Clark. What was it, 105? No object found. Clark 105. NGC 1499. Let's try that. NGC 1499. Aha. It's the California Nebula. Surely that's not right. Is that right? NGC 1499, yeah. Well, how about that? We're going to look at the California Nebula, supposedly. Boy, that is a beautiful picture. We've got a lot to live up to here if we're going to try to do that. So now let's go and put you guys in SharpCap. Boy, I wish we could get our resolution worked out. Let's make this 10 seconds and put this on 200 just for starters. Let's go back here and let's rename this and say, what are we called here? What is the, it's NGC 1499. NGC 1499. Now let's go to Tools and Plate Solve and Resync. Found it. Syncing it. Recentering. Okay, it likes it. Recentering on target. There's our recentering. Boy, plate solving is just the best. This corrects any errors that we have. I'm going to take a look outside at the scope. It is not colliding with anything, but boy, it did go a little bit past the meridian. Those counterbalance weights are up, but it's only about 15 degrees maybe. 10 to 15 degrees past the meridian. Boy, that's still not a lot that we're seeing there, is it? Let's reset this and this. And then let's, oh, look, there's something already showing up there, guys. Now let's go to the live stack and let's get this pinned again. And let's clear and let's bring this up so we can see that. And let's go, see, do I reset this first and then reset that? Reset this and reset that. Bring this over here, these over here, and then this. Look at that. Look at that. Boy, we do have a color balance problem. Look, we're not dropping any frames, so that's good. Oh, look right there in the middle. Yeah, now we've got. So I'm just going to go just bare. Now, last week you guys taught me that if I hold the shift key down and drag, it lets me drag a little more slowly. Now let's bring this mid-level in so we can see that. Wow, that's amazing. Now this object would be much more challenging. Let's do this reset over here again. And then reset this and this. And that. Look at that. Wow. That's amazing. This object is much dimmer than what we've been looking at. It is visually faint, but it is so large. It's in the constellation Perseus. Let's listen to the guy read it. So, oh, they don't have a. I don't think they have a recording of this. You're gonna have to put up with me. It's 2.5 degrees across, and the surface brightness is very, very, very low. And what they say here in the notes, guys, is it makes it a disappointing object. It's faint. It's just like a patch, and you can see some streaks. And it basically says you need really dark skies. Now I'm wondering how are we doing on our moon? Wow, our moon. Let's look and see how. Oh yeah, we are probably just. I'm looking at the scope, and I'm going to estimate we are just 20 degrees from the moon. And I bet you our targeting software probably will tell us because it's one of the things that the targeting software does. It actually tells us how far we are. Hope you guys are giving me instructions. I can't tell which instructions were for the last object. I can't tell. Move back to the left. Is that for this object? 9:31? It is. See, that's the way I can look at the time and I can go back. Reset the display histogram. That might be, boy, that is so beautiful though. Whoops, sorry. Snapshot in progress. Waiting for next frame. I don't need a snapshot. I hit the wrong button. Okay, let's cancel this and reset that. And do we use this auto stretch? I don't think so. And let's reset that and this, and then reset that and that. And then bring this over to right. Now see, was it Al? Was it you that said put that on top of the mountain? And then move this all the way over. And then bring this over till you see the nebulosity, right? That's just amazing that it can pull that out of what would be nothing if we looked up there. It would be so faint. Let's just pull this back for a second and just admire that. I mean, that is so cool. It's so beautiful. It's 1,000 light years away. And we're observing it. Uh, we're observing it on a night that the moon is so close to it that it's, to me, it's a miracle that we're able to see anything at all. Probably, truth be known, if we get this back up here, the reason why, if we move this close here, see all that light you're seeing there? I bet you anything that is moonlight, because the the filter that we have in this RASA scope filters out artificial light, but it does not filter out moonlight very well. What are you guys saying? Thanks for sharing, Doug. I do need to go. Yeah, thank you, Shelley, for coming. You're really kind. And you're saying Cheryl is saying it is beautiful. Frank's saying now you got it there. You move black to the left. Okay, so we're going to try to hold the shift key down, move the black to the left a little bit, and then play with this a little bit. Boy, that to me, if we get that black too far to the left, then we move this to the left, we get so much of that moon glow. But anyway, guys are going to take pictures of this. They'll aim their scope at this and they'll image for 3 hours, so that every last little photon they can grab in some light bucket drops in. Uh, for what we're looking at here, for 6 minutes of imaging, to me, I'm just amazed at this. Let me get this out of here again so you can see the best that you can. I'm just I am enthralled at this. It's the brightness in the center is due to vignetting. Well, I have flats, but I think my flats are not very good. Shadowstorm points out, yes, it is very large, too. Yeah, look how wide it is. And you're looking at the whole field. And my field on my RASA is like 1.8 degrees wide. This is huge. This thing is huge. So I'm going to go ahead and grab just a snapshot at this now of this, just to save it like we saw it, because to me, it's so amazing that you can see this and take one image brighter, one darker in the middle. Okay, so you're saying go like that? Okay, and go like that. Okay. Okay, I'll do that. I honestly think that I'll do better. Let me look over and see what you guys. Does that mean we have 13 people on? It looks like. Wow. I'm amazed that you guys have stayed this long. This is incredible for me being such a rank amateur. Yeah, 3 images. That's what we did. Larry Bentley, thanks for being here, Larry. You're very kind to come and stop by. We're glad. Honest, it's an honor to have you here, Larry. Thank you. Because I'm really an amateur at this. And the fact that you're willing to, next time I'll get this resolution fixed. This is just because I switched live streaming apps from SplitCam to OBS. And why did I do that? Well, it bothered me last time when I listened to the recording and I switched from one scene to the next. It bothered me that there was a jolt in the audio. And I thought, well, that is just no fun. Uh, so honestly, I thought, you know what? I think we should switch over to OBS and get rid of that problem. So in doing so, however, I, uh, I came across another problem, and that is the problem of not being able to have the resolution correct. So next time I will get that resolution correct. And I see what you're saying. I think it was you, Al, was it? Oh, Larry says bracket the images, one brighter, one normal, one dimmer. I think I did that. I see what you're saying, Al, about look, when you make it totally bright, you do get vignetting. So I'm gonna correct that next time. I'll tell you what I'm going to tell you guys also, because I imagine most of you who are left now are like with me through and through. I have another camera coming, and that's why I don't think I'm going to spend the time shooting new flats and darks with this camera. Uh, the new camera is going to give an even wider field and even greater sensitivity. And next time that we view, I think we're going to see even more possibilities here. So let me color balance one more time. Oh yeah, that did give us a lot different color balance this time, didn't it? Look at that. Let's try that one more time. It's really amazing. I guess I just think that by putting the blacks there, I get a little bit darker sky, and that lets me see a little bit more of what is that nebulosity, I think. Well, this is my first time to enjoy this NGC 1499, the California Nebula. I think it's interesting, isn't it, that Messier didn't catalog this object, and I guess he was observing from Paris. And I wonder if part of the reason he didn't catalog it was because he couldn't see it. I mean, back in the 1700s, with the telescopes they had, maybe he couldn't see the California Nebula. Well, we have about 20 minutes left on the broadcast. So I think what we're going to do is we're just going to do a quick observation here of this California Nebula. Make quick observation. And then we're going to go to this next object, which is the Crab Nebula. And we're just going to slew to that object. I'm going to take a look outside the window and make sure the mount, yeah, the mount is straightening out now. I didn't want it to go ahead and bump into the tripod, and fortunately it did not. Now we moved another 20 degrees maybe above, away from the moon. So I'm kind of glad of that. Now we need to stop live stacking, of course, because we're going to point at a new object here, and we're going to let's see, what are we looking at here? This is the Crab Nebula. So I'm going to name this. What could we call it? M1. This is M1. How about that? Sounds like a rifle or something. Then we're going to. What about our exposure? 10 seconds at 200. Let's start there, and let's do a reset of this. Wonder if we have to wait till our 10 seconds reset of that, and then let's plate solve and resync. Solving. Plate solve succeeded. That's always such a fun confirmation, isn't it, when you see that your plate solve succeeded. Okay, so what you're seeing there now, the fact that it's actually making a double image. You're seeing the old image that we had just taken, and it's mixing up with the new image that it's where it's resynced. I wonder if this is the object here. Let's go over for a second to Sky Safari, and in Sky Safari, let's search for M1 Crab Nebula. Yeah, it's the most famous and conspicuous supernova remnant in the sky. Centuries-old wreckage of a stellar explosion, first noted by Chinese astronomers in 1054. So let's center to that. And then let's zoom in on it here in our Sky Safari. So you see what our camera is supposed to see? And now let's go over to SharpCap, and that is exactly what we're seeing. So I just kind of wanted to confirm that's what it's going to look like. In our this rectangle is actually the exact field of view that our camera is supposed to have. Look, it's right there in the corner. So let's reset this and reset that one more time. We've got our name M1. Now let's start live stacking. Let's clear this. Let's get just a, oops, boy, that's messed up, isn't it? Now I've done it. How do I, there we go. Let's clear this one more time. And then let's do this and this and this and this. Let's reset that one more time and do this and this and this and this. And then let's move this over to about right. Now this must be what you mean when you say we're getting a double stretch. Move this over here, move this here. And then let's zoom in on that object the best we can. So what you're viewing here, can you see that? Let me make sure that you're seeing it. Oh, I can see it on my phone, can I? Yeah, it's just barely in your view, isn't it? Wait, are you looking at the, you're still stuck on Sky Safari, aren't you? Let's put you back in SharpCap now. Sorry. There you go. Now you're back in SharpCap. Um, I'm going to wait when that comes up on the screen. Oh yeah, you can see that. Let's zoom in a little more. If we can, what do we do? This? No, this. There we are. So what you're looking at here is a supernova remnant. Wow, that's kind of exciting, isn't it? You're seeing basically a star that exploded. And here, let's listen to the audio tour.
Remains of an exploded star whose other shell is still flying through space. Called the Crab Nebula, it is found just 1 degree from the star, marking the southern horn of Taurus the Bull. It was this object with its comet-like appearance that started Charles Messier on his famous list of deep sky targets. He wished to catalog objects that the unwary might mistake for comets. M1 is a faint glow, a little longer in one direction than the other in a 60mm telescope. In larger telescopes, M1 looks mottled, but does not look essentially different than the views in smaller scopes. The filaments and ejecta familiar in pictures taken with huge telescopes are not seen by the backyard astronomer. The crab, unlike many objects which are timeless in human terms, appeared suddenly in 1054 AD. In that year, Chinese astronomers noted a guest star at the position of M1. The new star was extremely bright for possibly 1 year and then faded away. The explosion of a star is called a supernova event, and this one must have been amongst the most energetic events to have taken place in our area of the galaxy. The edge of M1 is a shock wave that is still flying out from its heart at 80 million kilometers per day.
Wow, that's just really fun, isn't it? You are looking at the wreckage of an explosion. That's just phenomenal. Let's see. Are you guys 947? No. Oh yeah, here we are. Always reset the display histogram on the right before going to the live stack histogram. Otherwise, you have a double stretch. Okay, you got it. Nice. Well, that's kind of you to encourage. Um, I think this is fascinating. The fact that we can still see this, and that you're looking at what Chinese astronomers first noted in 1054. This was like an event for them. And at the center of this is a pulsar. It's a neutron star that's rotating 30.2 times per second. And it's basically, I guess you don't see that star in the middle because it's a pulsar. It's a pulsar. And of all things, it was July 4th, 1054. How about that? Now, it would have been really bright at -6. That's That's, as the narrator said, 4 times brighter than Venus, and it was visible even during the day. Think about that. Uh, for 23 days. Now, this is what I think of happening at something like the birth of Jesus, some kind of an event like this that astronomers might have seen. To me, this is just fascinating. Well, we viewed it about 5 minutes, and we've already got enough to be able to make our picture. I'm just gonna back off just a little bit of that white, but this is gonna make a nice shot, I think. And you'll be able to tell everybody that you visit with tonight that you watched a supernova live. How about that? We have about 10 minutes left, and I wonder if anybody has any questions. Feel free to ask those. I'm just having a blast, and I'll probably be out here much of the rest of the night. I think before we go, we'll go to one more target, and that is, oh, wait, while we're on Crab Nebula, let's just say, make a quick observation so we know we were there, and let's go to Pleiades. Did we stop live stacking? Let's make sure we did that because that's probably a kind thing to do. Stop live stacking, and then let's switch you back to the targeting software, um, Astro Planner, because that's what I go to next. You're not able to see much of it, unfortunately. Now we're gonna see what I'll do after we are done. I will hook up this webcam and figure out how to get a view of the scope because I think it's kind of fun for you to see the telescope slew and you hear the whirring of the engine. Um, it is in the process of slewing right now. I'm just looking at all my gear. Everything's okay. Tonight, I have a new battery because last time I actually ran the battery down all the way. It was a Celestron, I don't know if I have maybe the replacement battery I have in that power tank is probably now 8 amp hours. Is that what they call it? But now I've got one of these Celestron 17 amp hours. And so what I have is the dew heater and the mount running on, or the dew heater running on one, and then the mount and the RASA uh, distribution fan, the air distribution fan on the RASA running on the other. So that way I won't wear out the battery tonight. If I'm out here 6 hours or whatever, Lord willing, I've also got a nice little red light out on the mount and the scope so you can kind of see it a little better. And then when I slew manually, I shine a flashlight out the window. So I'll get that hooked up so you can see like the dew shield on the front of the Rasa. You'll be able to see the tail rad there. You'll see the dew heater with a band that's wrapped around the end of the scope so that it keeps the front uh, corrector plate from fogging over with dew, which happens in like 20 or 25 minutes on a Rasa because they've got that corrector plate right out the front. It's just kind of fun to see all that happening. And it's a very cold night. Like I say, feels like 24. Larry Bentley, most most of the angular momentum of the parent star swayed when the core shrunk down. The very small diameter, thus the very fast rotation. Larry, I didn't even know you're really deep into this, aren't you? That's awesome. I didn't know this. Okay, so let's go back now to Sharp Cap, and we're in our last 8 minutes here. So let's hurry up and get this in. We're looking at Pleiades. So we're going to go back out because this is a wider target. And let's do our plate solve and resync. In fact, the Pleiades, it's such a big target. I doubt if we can even get it all in this scope. Now, in this camera, the camera that we have coming, maybe we can get all the Pleiades in it, but this one, I don't think we'll be able to. Let's see, we're at 10 seconds and 200 gain. That's probably not a bad setting for Pleiades. Boy, it thinks it's centered it up, huh? I wonder if we ought to use our arrows here and try to go See how there's some dark space over on the right side? Yeah, I think I'm going in the right direction, aren't I? It takes me a time or two when I'm using these manual arrows. It takes me a time or two to make sure I went in the correct direction because of the fact that the Rasa does reverse. I always have to stop and think. But what I do, I've got the camera now so that it update the target name. Thank you so much. And Pleiades is M45. Boy, thank you guys. All these sequence of things. Let's go over just a little bit more, in fact. Uh, Al, thank you for coming. You're very kind to say great session. What a rough start I had because of that. I couldn't, for some reason, get the mount to respond at first, so I wasted 30 or 40 minutes. But the good thing is on the recording, I'll whack all that off, you see. So I'll save some face um, on the recording. The people who just watch the recording, they won't know that that I had such a hard time getting my green swamp software, whatever server software, to talk to the mount. They won't know that I messed that up. We're in our last 5 minutes, and we're zeroing in on Pleiades here. Pleiades. This Pleiades has always been interesting to me because it is visible with the naked eye. It's the kind of object that you can find in the middle of the night. Some people say that it looks a little bit like a tiny, tiny dipper. And I don't know how much of that dipper we're going to be able to see in our field. I'm trying to kind of get it here more centered in what I would think of we would want to see. Let's see, 1, 2, 3, 4, 5, 6, 7. Maybe we've got all 7 in now. Who knows? I'll sort that out. But let's go ahead. Since we just have 5 minutes left, let's just take that as it is. And oh yeah, isn't that beautiful? You think that's everything? Yeah, 1, 2, 3, 4, 5, 6, 7. You think that's it? 2, 3, 4, 5, 6, 7. I think that's it. I think we've got the whole Pleiades in our view. So this does work out well for a Rasa with I have the ASI 183 MC Pro. So now let's clear our live stack and put our black all the way over here somewhere. And we might. There, we're starting to see some of that nebulosity around Pleiades. Isn't it really a beautiful? It's a beautiful formation, though, isn't it? Let's listen to this audio tour.
M45 is the Pleiades star cluster. Called the Seven Sisters, it is a naked eye tight knot of 5 to 8 stars depending on conditions and the watcher's eyesight. Since the Pleiades require no optical aid to observe, it has been known and named from the earliest times. The name Pleiades seems to mean full, and this is the impression of the eye when seeing these stars. It looks to the naked eye like many open clusters do in the field of view of a telescope. Since the Pleiades are so large and clear, they are best viewed with small telescopes or binoculars. Large telescopes spoil things, and M45 can't be fitted into the narrow area of the high-powered instrument. Pleasing views are obtained in 7-power binoculars, or even in opera glasses that magnify 3 or 4 times. Here the Seven Sisters now become 30 or 40. The cluster has several hundred members, but its riches can be easily sampled in a handheld glass. The object is set in a faint nebula, but photography is usually required to see much of this. Most stars in M45 are bluish, and it is one of the youngest star clusters in the heavens.
How about that? This is where I think um, electronically assisted astronomy, perhaps this is one of the best examples of why I am liking EAA so much because we can catch, for instance, that nebulosity. Did you hear him say that you normally had to resort to photography to be able to see the nebulosity? But see, we are seeing it live here, and that's only going to happen in a scope like this, I think, where we're able to use the advantages of a camera while we are looking at it live. Isn't that amazing? And notice with a wide field scope like the RASA, we're able to enjoy the entire object, uh, which you know normal high like 8-inch scopes might look in on one or two of these objects, but because of the RASA being what it is, it lets us enjoy this really wide field. Look at the beautiful little dust lanes, all that star material that's just being poured out there. And you can almost see, look at, you can make out a little bit of dark there. And I don't know if that's dark nebula in front of those dust or if that's, I guess that's what that would be, dark nebula in front of that dust. And now we're able to appreciate what they saw with their sharp eyes in the remember a while ago when we were reading the scripture passages from the Bible, and this is like literally thousands of years ago, he who made the Pleiades and Orion, and turns deep darkness into the morning, and darkens the day into the night, who calls for the waters of the sea, and pours them out on the surface of the earth. The Lord is his name. Amos 5:8. Job 38:31. Can you bind the chains of the Pleiades or loose the cords of Orion? Uh, Job 9:9, who made the bear and Orion, the Pleiades and the chambers of the south? Uh, to me, this is amazing that we can look at an object that they viewed thousands of years ago, and the light that we see has been coming to us for literally, I mean, if you think about the Pleiades and the fact that it's 430 light years away, we are looking at light right now that left these objects 430 years ago, and it's been traveling through space like a little rocket ship. And tonight at 10 p.m. at Emerald Hills, just on the outskirts of Louisville, with the moon shining at 50% brightness and all of the light pollution of Louisville, we can pierce through that and let some of those tiny photons that have been traveling through all that space for 430 years, and those tiny little photons land on those little bitty CMOS chips inside of that ZWO ASI 183 camera, and they begin exciting those electrons so that it can send that message through this cable here on the inside of this Ford Expedition so we can see it now on this computer screen. And instantly we can live stream it to you so you can enjoy it from your couch without ever leaving your house. Now, is that not cool or what? Hey, thanks a lot for being a part of this tonight. We are going to end the live stream, but uh, we encourage you to go to emeraldhillsskies.com and sign up with your email address there in that blank. The only thing that it will be used for ever. It is completely separate from anything related to team expansion, completely separate from any kind of fundraising list or anything like that. You are in a private list that's completely separate. And all it's going to do is notify you of nights like tonight when we are out here underneath the Emerald Hill skies, and we'd like to invite you back. Thank you so much for being a part of this. Thank you, Shelley. Thank you, Al. Thank you, Frank. Thank you, Larry. Thanks to all of you who are involved. We still have 9 with us, although not all of you have checked in with your name. We still appreciate you and thank you for being a part of this. And those of you who are going to watch this on recording on the site, thank you for being a part of this. I want to promise you, give you my word, I will continue to try to figure this out so we try to sort out all of these resolution issues and make these objects bigger for you to see next time. Chris Bushnell, after working, I bet, all day long in a hospital, seeing COVID patients galore and everything else you were doing, and ERs and going back and forth between dozens and dozens of patients, the fact that you stayed up till 10 o'clock tonight means the world to me, brother. And may God bless you. Thank you for being a frontlines person there. I know you've already gotten one of your COVID, your first part of your COVID vaccination. We just pray tonight that God keeps you safe in everything that you're doing. And thank you for being there so you're keeping all the rest of us safe. And then all the people that have normal illnesses, so you can work on them as well without spreading COVID to them because you've taken care and been safe. Boy, God bless you, Chris, and thanks for checking in. We like to say good night to everybody, and we look forward to seeing you next time. If you sign up for that notification, you will get an email at least a couple of days in advance. And boy, I'm just going to pray and hope, and I hope you will as well, that next time we'll have a better stream for you to watch. God bless and